Okay, here we go with an electric fields question. We're looking at the net electric field strength at P, when we've got two positive charges, X and Y, and we're going to use vector analysis to do that. As ever, hit pause, try the question, and then press play. Okay, something just to set us up at this point to recognize, if we are at the point P, we should be aware that whenever we think about electric field strength, we imagine what would happen if we put a tiny positive charge at that point P. So imagine I put a small point here. We're going to wonder what happens to that. Well, X is positive, it's going to push to the right. Y is also positive, it's going to push to the left. So hopefully what you can see is if I want to get the total electric field strength, which is what we're looking for, the net electric field strength, I need to find the difference between these. So what I'm going to say is that X pushes to the right, that's going to be positive. Y pushes to the left, that's going to be negative. We're then going to calculate. Okay, if we're at a position, a distance, of D away from X, we know the charge on X is just KQ over D squared, where this comes from our equation for the electric field around a point charge. On the right hand side, we've got a slightly more complicated one. We've got charge equal to 2Q, so that's going on the top, and we've got a distance 2D. And we notice that that 2D is going to get squared. So we're going to just work through the maths here. We've got KQ over D squared minus 2KQ over 4D squared. Well, 2 and the 4 are going to cancel to produce a 2 on the bottom. In other words, we're going to get an electric field strength of KQ over 2D squared, which is why the answer here is B.